All right, welcome everybody. Today we're going to talk about Calc Lesson number 12, and this is talking about section 2.3, which is the product rule for derivatives. So before we get into the actual specifics of what the product rule is, of course, product means multiplication. Let's say that you were given a problem like this, h of x equals, and you were asked to find the derivative. Currently, since you don't know the product rule, the way that you would take the derivative of this question would be to start by actually multiplying the polynomial out and then taking the derivative one step at a time. So why don't we go ahead and do that first, just as a good review. So you're going to go ahead and use the magic word, which of course would be to FOIL. So if you multiply your first, you get 15x, your outers, 12x squared, your inners, negative 10x squared, and finally your last would be negative 8x cubed. Let's go ahead and combine like terms and write it in standard form. So negative 8x cubed would be first, plus 2x squared, and then plus 15x. Notice this is still h of x because of the fact I haven't taken any derivatives yet. All I've done is kind of done some algebra. Once I'm actually ready to go ahead and take the derivative of h of x would be h prime of x. And you would go ahead and take the derivatives one at a time. So bring down the 3 times negative 8 would be negative 24x squared. Plus, bring down the 2 times 2 is 4 to the 1 less power x. Plus, the derivative of anything times x is always just the constant, which in this case would be 15. So the derivative of h of x is negative 24x squared plus 4x plus 15. And again, hopefully that is just a good review of what we've done so far. Now, what I did here in the first example is a perfectly fine way of doing the problem, and I promise you would get the right answer. But we, of course, want to try to be as efficient as possible in all cases, which is where the product rule comes in. So here is the product rule. You probably definitely actually will want to write down this formula. And again, it is found on that big formula sheet that hopefully you have printed out by this point. So here's what the product rule says. If you are taking the derivative in terms of x, which again is d over dx, of two functions being multiplied times each other, f and g, you're going to take the original f multiplied by the derivative of g, and then add it to the regular g multiplied by the derivative of f. The way that we probably will say that is the first times the derivative of the second plus the second times the derivative of the first. So be very careful here. This product rule only works if you are multiplying out exactly two things. If you are multiplying out three things, there's another rule, which we're not actually even going to get into, but make sure you know that it only works if you are multiplying two things. So again, it's the first times the derivative of the second plus the second times the derivative of the first. So we're actually going to go ahead and do that first problem again, now using the product rule. So notice I've written the product rule up here in the top right-hand corner so that we have easy access. And again, notice that this is the same h of x that it was a few slides ago, and bet you $1 million we should in fact get the same answer. So notice what I've done here, which a lot of people do find helpful, at least while they're still getting comfortable with the product rule, and that's to make yourself a little key. I have written what's f prime, what's g, and what's g prime. If you go ahead and write this out, some people just find it helpful to then go ahead and slot the answers into the formula. The better you get at using the product rule, you might not have to do this all the time, but I actually do think it's a pretty good strategy while you're getting started. So your f of x is, of course, the first function, which would be 3x minus 2x squared, which would make your second function 5 plus 4x. And just so you know, it actually wouldn't matter if you switch the f and the g, you'd still get the same answer, but why not just go in order since that makes everybody's life easier? Then if you're finding f prime, that means you're going to take the derivative of f. So the derivative of 3x would be 3 minus 4x. The derivative of 5 is 0. The derivative of 4x is 4. So now that you have found this key, all you're going to do is apply the product rule by plugging the numbers in or plugging the values in to the appropriate location. And of course, if you're taking the derivative of h of x, we're going to call that h prime of x. So according to the formula, we're going to take the first, which is 3x minus 2x squared, times the derivative of the second, which is 4, plus the second, 5 plus 4x, times the derivative of the first, which would be 3 minus 4x. Now that I have all the values in the appropriate slot, I'm going to go ahead and do any multiplication that I need. So this is going to give me 12x minus 8x squared. Then I'm going to have to go ahead and FOIL. So that's 15 minus 20x plus 12x minus 16x squared. And my final answer, which is h prime of x, I'm going to go ahead and combine like terms, and I'm going to make sure that I put it in standard form. So negative 8x squared, negative 16x squared, that's a total of negative 24x squared. This is a 12x plus a 12x is a 24 minus 20 gives me a positive 4x. And then that lonely little positive 15. And here is, in fact, my derivative. And if you were to go back a few slides, you would absolutely see that the answer that you get for the derivative using the product rule is the same as the answer that you would get if you were to multiply it out and then take the derivative one at a time. So again, for a problem like this, either of these methods would be acceptable. And then, of course, there are plenty of problems where the product rule is your only option. So we would have to use it in those cases. So let's go ahead and take a look at the next example here. Find the derivative of y equals 3x squared times the sine of x. The number one mistake that people make on this test, and I'm sure some of you are going to make it, is they're like, oh, let's just take the derivative of 3x squared and then take the derivative of sine. That is not a thing. You do not get to make up your own rules. You have to follow the rules that the mathematicians have made and proved and worked for years and years and years. So this is a product. Whatever the first thing is, that has to be your f. Whatever the second thing is, that has to be your g. Again, you don't get to make up your own formulas. I have been working on the Lipinski theorem for years, and so far, nothing. So you don't get to make your own theorems up on the fly. So now that I have my f and now that I have my g, I'm going to go ahead and take the derivative of each. The derivative of 3x squared is, of course, 6x. The derivative of sine, whether you remember or have to look at your formula sheet, is the positive cosine. So because this problem was a y, we're going to call the derivative y prime. And again, using the formula, it's going to be the first f times the derivative of the second, which would be cosine, plus the second, which is the sine, times the derivative of the first, which would be 6x. Here's the thing, you can't actually multiply a cosine times a 3x squared, and you can't multiply a 6x times a sine x. So all you can do is simplify, and by simplify, that means factor out any of the common factors. So this is 3x squared times the cosine, and this is 6x times the sine of x. So you can factor out the greatest common factor, which would be 3x. If you factor a 3x out of each term, you'll be left with an x cos x plus 2 sine x. And that would be considered to be your answer. So again, there are eventually so many things that you are going to do with this derivative. You're going to set it equal to things, you're going to solve for things, you're going to graph things, but for now, you just have to be able to apply the formula. So using this little setup here of f prime, g, and g prime, not required, but I certainly would consider using it, at least while you're still getting familiar with the product rule. Take a look here at the next example. So find the derivative of y equals. And what you hopefully will notice here is that you do have to use the product rule, but then you also have to take just a regular derivative. So this right here is an example of taking the product rule, where this here is just a regular derivative. So I'm going to do my key for 2x times the cosine of x, and then I'm going to take the derivative of negative 2 sine x on its own. So using my little key here, I'm going to call this 2x, and I'm going to call this the cos. The derivative of 2x is, of course, 2, and the derivative of the cosine is the negative sine. Again, that's just the rule, so you don't have to memorize it. You can just look at your sheet. We'll call this y prime. And again, it's going to be the first 2x times the derivative of the second, which would be the negative sign, plus the second, which is the cosine of x, times the derivative of the first, which is 2. And then don't forget to actually take the derivative of this lonely negative 2 sine of x. So the derivative of negative 2 times the sine of x, leave the negative 2, and the derivative of the sine of x is the cosine of x. So again, please just make sure that you don't forget to take the derivative of everybody. Hopefully you realize that when you include that minus 2 sine of x, this positive 2 cos cancels out with this negative 2 cos, which means that my derivative y prime, I'm just going to simplify and write this as negative 2x sine of x. So that's my final answer, just those two things multiply times each other. And again, it's considered proper notation to put the negative out front, then the constant, then the single x, and then the sine of x. So negative 2x times the sine of x is the final answer to this problem. If you're wondering why we use the product rule for the first part, but not the second part, I'm going to go ahead and give you just a little description. When do you use the product rule versus when don't you use the product rule? So if you take a look at these two problems, the left one in black and the right one in red, they do obviously look quite similar, but the biggest reason why you would use the product rule on the left is because this is a 2x. If both of them have variables, you're going to use the product rule if both functions have variables over here on the right. Notice that the 2 that's out front, this is simply a constant. So while in the left example, you would have an f and then you would have a g, you just have 2, which is a constant, and then you would consider this to be your f. So there's no need to use the product rule for the one on the right. You could, to be clear, but a much easier way to do it, to find the derivative, would be to leave the 2 and then just multiply it by whatever the derivative of f is. So if one of the values is a constant, the product rule is not required. Again, you could do it if you want to, but hopefully you would recognize that the problem on the right is a much easier version as compared to the problem on the left, and so you should treat it as such. And then again, in both of these cases, you could distribute through and then take the derivatives one at a time, but because this is a lesson about the product rule, we would strongly suggest that you use the product rule for every question because you're trying to practice that technique. Okay, another example here, find the derivative of the sine times the cosine. So your f is going to be your sine, where your g is going to be your cosine. Your derivative of a positive sine is a positive cos. Your derivative of a positive cos is a negative sine. Let's just have a little fun here and call this one dy dx as opposed to calling it y prime. Remember, it eventually matters, the notation, but for now, it doesn't. So you're going to go ahead, first sine times the derivative of the second, which is the negative sine, plus the second, which is the cos, times the derivative of the first, which is the cos. Here you actually can simplify a little farther because it's dy dx. You can multiply a sine times a negative sine, which gives you a negative sine squared. And please make sure that when you write sine squared, make sure that the squared is between the sine and the x. It has to be written exactly as I've written it, plus the cosine squared of x. And again, make sure that the squared is in the middle. So that is in fact your answer. It is in fact your derivative. If you're thinking, sine squareds and cosine squareds, those usually go together to make a 1. You're right, but only if it's addition. So sine squared plus cosine squared, that would make a 1, but negative sine squared plus cosine squared is not a thing. So you're going to go ahead and leave it exactly like that. Couple more here. And again, obviously, it's getting slightly more difficult. So you're going to have some fraction action. You're going to have some negative exponents. And then notice I brought my formula back up at the top there as a reference. So as I go to write my first, I'm going to write the square root of x as x to the 1/2 power. Then I'm going to write my g as 4x squared minus 3x. The derivative of x to the 1/2, you would bring down the 1/2. Then you would take your x to the 1 less power. The derivative of 4x squared, bring down the 2, 8x minus 3. Let's call this one y prime. And then very carefully, it's the first, x to the 1/2, times the derivative of the second, which would be 8x minus 3, plus the second, which would be 4x squared minus 3x, times the derivative of the first, which would be 1/2 x to the negative 1/2. So you have to simplify this. There's a couple of different ways that you could simplify. You can factor out the greatest common factor, or you can distribute through and then combine like terms. In this case, either one would be acceptable. We'll go ahead and multiply through, since that does wind up being slightly easier, as long as you know your rules of exponents. So if you're multiplying x to the 1/2 times 8x, 1 times 8 is 8, and then you have to add the exponents. So you would be adding 1/2 to 2/2, which means you would get 8x to the 3/2. If you distribute to the negative 3, you would get negative 3x to the 1/2. Then anytime you get something like this second quantity here, please be advised, you could put the 1/2 x to the negative 1/2 out front, which most of you would prefer because it's a little easier to see how you distribute. Here, you're just distributing the opposite way, which is the same thing, but feel free to invert those two values if you think that it's easier. So 1/2 times 4 would, of course, give you 2. And then if you were adding 2 to negative 1/2, that really means you're adding 4/2 to negative 1/2, which would give you x to the 3/2. And then if you multiply negative 3 times 1/2, that would give you negative 3/2. If you were adding the exponents, that's x to the first, which is really x to the 2/2, plus x to the negative 1/2 is x to the 1/2. Yeah, that kind of escalated quickly. They can't all be as easy as the last couple. So we gotta, calculus it up a little bit. And then for your final answer here, you're just gonna go ahead and combine your like terms. So notice that you have 8x to the 3/2 plus another 2x to the 3/2, which is of course a total of 10x to the 3/2. Then you have a negative 3x to the 1/2 and a negative 3/2 x to the 1/2. That's really like saying negative 6/2 plus negative 3/2, which would be negative 9/2 x to the 1/2 power. In terms of the order that you should write it in, because 3/2 is larger than 1/2, that's why I just chose to go ahead and put that first. And again, there will come a time, sooner rather than later, where you'll have to factor that farther, set it equal to stuff, and solve. But for now, you literally just have to be able to apply the formula. So I believe this is our last problem here. Find the derivative. And again, looks a little bit more complicated, although I promise it's not too bad. So you're going to go ahead and take this to be your f. And when you write it, I'm going to write 1 over x as x to the negative 1, because that is easier for which to take my derivative. That would make my g x minus 1. The derivative of x to the negative 1 is negative x to the 1 less power. And then the derivative of 1 is, of course, 0. The derivative of x to the first is just 1. The derivative of negative 1 is a 0. Let's call this one y prime. So again, you're going to take your first, which is x to the negative 1 plus 1, times the derivative of the second, which would be 1, plus the second, which is x minus 1, times the derivative of the first, which would be negative x to the negative 2. Go ahead and combine your like terms by multiplying through first. So if you distribute this 1, you get x to the negative 1 plus 1. If you distribute this negative x to the negative 2, x to the first times a negative x to the negative 2, that's a negative. If you add the exponents, 1 plus negative 2 gives you negative x to the negative 1. Then if you multiply these, you get a positive x to the negative 2. And look at that, life is grand because a positive x to the negative 1 and a negative x to the negative 1, that in fact cancels. So your answer is a 1. And then I don't like that negative exponent, so I'm going to write it as 1 over x squared. We're going to call this, again, y prime. It is, in fact, my final answer. And remember, at some point, you might be asked to find a common denominator on a test or quiz. It will be abundantly clear how far you should go. For now, you can just go ahead and stop there. So here is Calc homework number 12. All of these problems, I strongly suggest you use the product rule. Even if there are some problems that can be done by foiling or distributing, because this is a lesson on the product rule, we would strongly encourage you to use the product rule.